Greetings, dear alert physics students. Welcome back. Today we start chapter 2 with a short video. I think it'll be fairly short, maybe 10 minutes, over position, distance, and displacement. Now, we're not going to cover all of section 2.1 in this lecture. That's why it's called 2.1a. There will be B coming up next. We're going to concentrate in this lecture on the first of these. We're going to mention the second two. That's why I put all three of them up there. But we're going to concentrate on position, this idea of position, whatever that is, and then get on to distance and displacement. In physics land, which is where we're living at the moment, these words, position, distance, and displacement, have very particular meanings. And let's look at what position means. Okay. Now, here we have a situation. We've got two houses and Publix. A little drawing here. Maybe I should have added some trees, some birds, who knows? But I didn't. Let's see. I can at least add the sun. So let's say that we've got these two houses, your friend's house, your house, and Publix. And we're going to talk about the positions of these objects, of these places. Okay? The first thing we have to do to talk about position is to take this nice little cartoon here and impose a coordinate system on it. We're in physics, so there's going to be numbers and stuff, and so we need to have coordinate systems. And so what we do is it's kind of like a number line. Okay, we pick a direction to call positive. Let's make this blue line the coordinate system. And let's say that this direction is positive x. Okay, so we're turning the ground here into a number line. And all number lines need an origin. Okay, so let's call your friend's house x equals 0. That's the origin of our number line. Now, let's say that I have not drawn my picture here to scale, really, so that you live not right next door as it appears in the picture, but let's say that your position is 2.1 miles. MI stands for miles. So you are 2.1 miles this side of your friend's house. Okay. And let's say that the position of Publix, let me get my numbers right here, is 6.4 miles. So x is the position, okay? X is the position of these three places on our coordinate system. Notice that we have called the right positive. Going to the right is positive, and what that means is that as you go to the right, you increase. If there was a third house down this way somewhere, it would have a negative position. Might be x equals negative 7 miles. Okay. So that's where these different objects, these different residences and different buildings, buildings is the best word, buildings line up on our coordinate system. Okay. That's where they line up on our coordinate system. So those are the three positions. Okay. So when we say position, in physics, we're talking about a location on a coordinate system. In this case, we're dealing with in this chapter. It's not up here at the top of the board, but this chapter that we're starting, should have said this at the very beginning, is about motion in one dimension. Okay, and in this example here, that dimension is the x dimension, the x direction. This is a one-dimensional drawing in the sense that the three different buildings are indicated by a single, their location is indicated by a single number. If we were living in 2 or 3 dimensions, we would need 2 or 3 numbers to indicate the position of a building or of a bird or of any spaceship or whatever. Okay, so this is one-dimensional motion we're talking about. Okay, and I could have put that at the top, but just to be clear, we're talking about one-dimensional motion. And basically, for our money, that means motion along a single line. Okay, in this case, we've called that X. That line we've called X. If it was vertical, we'd call it Y, but it's horizontal, so we call it X. But this is really what this chapter is about, one-dimensional motion. All the motion will lie along a single line. Okay. So notice here that as you go right, the coordinates, the positions increase. As you go left, they decrease. That's what the positive X means here. As you go to the right, it increases. Okay? So that's position. That's position. What I want to do before we move on to the next section is I want to define for you, at least throw out there so you can see it, what the difference between distance and displacement is. Okay? Distance and displacement. So let's define distance here. Okay. Distance is defined by our textbook as basically total length of travel, sometimes simply called path length. Total length of travel. Okay. Total distance of, I can't use the word distance, that's what we're defining. But distance is defined as the total length of travel. And the distance D, I'll just write out distance, is defined as, how do I have it written here? Where'd it go? Yes, pardon me. Pardon for the pause there. Distance is defined again as, this is the definition of it, total length of travel. Okay? In other words, as I've already indicated to you, this chapter is about motion in one dimension, which means we're going to consider objects moving along this number line. It could be you walking to the store, walking to your friend's house from your house. Okay? So distance is simply total length of travel. Okay? That is the definition of distance. And in the next lecture, next video, we're going to unpack this and we'll do some examples. I'm just putting these definitions up here so you can see them. So when we get into the next video, you will have been acquainted with them. That's all. Distance is total length of travel. Okay. Displacement is something different. Displacement is defined as, mathematically, it's delta x. It's defined as x final. The subscript on that x means final, minus x initial. The final position minus the initial position. So in both cases, distance and displacement, we're talking about somebody moving, say you moving from your house to Publix. Okay. You have covered some distance in that trip, and you've also undergone a displacement in that trip. And we'll see that in some cases, distance and displacement are the same, and in some cases, they are not the same. Okay, again, don't worry about not understanding exactly what we have here. I simply wanted to put the definitions up here because I'm going to refer back to them in the next video. We're going to spend the next video unpacking these two definitions. Okay? But both distance and displacement are things that happen on a single line. And in this chapter, we'll not only be dealing with horizontal lines, things moving like left and right, we'll be dealing with things moving up and down, such as freely falling bodies. When I take my pen and I drop it, it falls in a single dimension. We call that dimension, that vertical dimension, y, right? But it's moving down along a single one-dimensional axis. So both you walking to your friend's house, you walking to Publix, that's in the x direction, and my falling pen, that happens in the y direction, but both of these are examples of one-dimensional motion. And that's what we're talking about. In later chapters, chapter 3 and on, we're going to talk more about two-dimensional motion. We're not going to say much about 3 in this class, but we're going to get into two-dimensional motion. And then next semester in the spring, we're going to have to get into a little bit of three-dimensional stuff. Okay? But that's it for this lecture, and I'll see you next time when we'll talk about making more sense of what these two things are, distance and displacement, and giving you an example in our little world here to see how sometimes they look the same and sometimes they look different. See you then.